All right, we are going to continue learning about Docker. Today is going to be a bit more of a hands-on workshop. Let me kind of go over the agenda. Um, is this font size good? Can everyone read this? Awesome. Also, so FYI, my terminal's over here. We're going to be spending so much time in the terminal today that I figured it was easier to read if I kind of put it off to the side so that we could have whatever file we're looking at on the left. So this is my terminal. I'll be honest, it's somewhere in here you can tell VS Code to put the terminal in a tab. Um, you can also do stuff like that's not what I wanted. You can position it, like move terminal into editor area, move terminal into new window. And at the moment, I also don't remember how to put it back, but I think this is a good way to do it. So just hopefully that's not too confusing. I'll try to keep it kind of at these proportions. So the plan for today is we were just going to do a brief review of a lot of the concepts that we talked about last time, like why Docker, why do we care, why is it important? Then I'm going to show you guys a full stack web app that's already Dockerized that we have, and we're actually going to clone that down and run it. So as long as everyone has Docker Hub, um, then you should be able to do this, and we can kind of see the cake we're going to bake, so to speak. I'm going to talk very briefly about a Docker image versus a Docker container. I think that's a common point of confusion. And then we're going to get into sort of hands-on coding along. And you guys saw me running some Docker containers yesterday with Linux, and we're going to do that. We're going to like add stuff too. We're going to install things. We're going to talk about why. So there's two ways to add stuff sort of to a Docker image, a bad way and a good way. We'll start with the bad way, talk about why it's bad. Then we'll talk about the good way, which involves Dockerfiles, and we'll actually make a little Docker file. We'll build a new image. We'll push it to Docker Hub. We'll build another image from our old image. And that's really the main agenda for today. If there is time, we may play around with the Nginx Docker container that you all saw me messing with earlier in the week. But as a code along, I think this could take possibly the full hour. And the goal here really is, I think it's important to get your hands dirty with something to help really understand the concepts. And once I think it'll help us all feel a bit more comfortable with Docker. And then tomorrow and next week, we'll see how to Dockerize all the different parts of a full stack app. Do folks have any questions about the agenda? Cool. Okay. So why Docker? And James Byers, you asked a great question earlier in the week. And it kind of led me to showing this diagram, which normally I don't talk about till later, about the different environments that in the real world we have to think about deploying our system onto, right? Because the truth is, with a database and an API backend web server, and then if we have a different web server hosting our front end, right now we use the Vite dev server, but we're going to use this web server called Nginx for production because Vite dev server isn't meant to like be used for something hosted live on the web. You don't want hot reloading where when you change the code, the page refreshes to happen on a live site, for example. We have a system here. It's separate programs that really can end up running on different computers and interact with each other. And as I mentioned last week, you know, the real world engineering things to think about is, first of all, local dev. Now that you guys are collaborating, and can you all see this diagram okay? I know I zoomed out a bit. Can you read it?
If you could zoom in probably about 2 clicks, that would be good.
Yeah, totally. let's see here. Um, yeah, this is a good start. And actually, I don't know why, but this part of the diagram is missing a bubble. This is my sort of ad hoc icon, right? So each of these is a Docker container running a Docker image. And we eventually will have separate containers for our Django backend, our Postgres database, and the Nginx web server that's going to host our React app, our front end. And then over here is the browser, right? The user's browser. Um, always tempted to one day we'll come up with a good browser joke. And again, for the entirety of the class, you guys have really had this stack minus the Docker containers running on your laptop. But each part of this system, the client, which is the browser, which is actually running this stuff, and the web server, which is vdev server, and Django, our backend API, and our database have all run on the same physical machine. Um, and first off, you've only needed to run it on your machine. And now, first that you have to share it with 3 or 4 people on a team, you guys may have already encountered some pain points, and you could imagine where if there's like a one-click way to do this, that might make life easier. Um, the real consideration is when we have to start thinking about production. And if you're working at a company, once we have a new feature, if we're working for Amazon, we're not just going to throw it live on a big, billion-dollar website. We're going to test it out. It's going to go into a QA environment in the cloud that has tons of probably old real data, um, or fake data. But for a company as big as Amazon, they would actually use real data, and there'd be a manual QA process. So we have to take our system and deploy it here. And, if I'm using a different version of Ubuntu Linux or a different version of Python, that can really mess stuff up. So having the exact same stack all the way down to the programming language and the operating system itself is incredibly valuable. And truth be told, at Amazon, there's product managers, there's designers for an important feature. We might want dozens of people across the country or across the world to be able to interact with it and give feedback on it before it's even kind of finalized and ready for QA. So there's probably in the cloud some staging environments for developers to put features that they're working on for review. So I need to be able to take my code in my system and put it to multiple cloud environments and then finally into the live production environment. And we need dozens to hundreds of developers to be able to do this consistently all the time and the same way. And that's so the DevOps program delves into a whole lot of that, but Docker is a key piece because it lets us reproduce the exact same operating system, the exact same environment for our code to run in. And I just want to check in and see if there's things that people are curious about that it might be good for me to dig into more, or if as I'm talking about this stuff, there's parts of what I said that didn't make sense because sometimes it's easy for me to make an assumption without realizing it. So if there's parts where it felt like Adam, I'm not sure I'm tracking, let me know what's on people's minds. We feeling pretty good? Cool. So this is the problem, and Docker is the solution. We talked a lot last time about Docker versus a virtual machine. The big thing with a virtual machine is that it's heavyweight. It's way more heavyweight than Docker. It simulates the whole operating system. And this is absolutely used in modern data centers, and this is like what the cloud is built on. Um, they might be using containers more and more, but for a long time, a data center had these beefy physical servers, with tons of power or lots of cheap ones. And when you signed up to get a server on a data center through a hosting service, they made you a virtual machine so that both for security and simplicity. If we're a hospital, I don't want my hospital web app with private, patient data to live on a server with really any other company for security reasons at all. And so the virtual machine is important for that as well, in that it provides like a strong separation between things, which is an important security feature. What Docker brings to the table is it's basically a lightweight virtual machine. Docker only runs on Linux, right? It has this thing called the Docker engine that's sort of running in and keeping charge of everything. But because it runs on Linux, all the different Linux operating systems out there, we've really only seen Ubuntu, but there's Fedora, there's Arch Linux. On Docker, there's a tiny, tiny version of Linux called BusyBox. Mac OS X is, if you dig deep down enough, it's Linux based on, I think, Debian, another kind of Linux. They all share a kernel. Um, but there's a lot of other stuff as well. And so a Docker container is part of this thing called a Linux container, and they share the kernel and they share a bit of memory. So there's less security, but it's way more lightweight in terms of resources, in terms of complexities that go along with using these things. It's dramatically more lightweight. And so this company Docker took this Linux container thing and like built tools around it, and it kind of took off like hotcakes. And there's competitors to Docker now. There's other sort of Linux container companies out there, but they're still sort of the big boy in that space. And so hopefully everyone has gone and created a Docker account. You should be able to go to Docker Hub, hub.docker.com, and be logged in. I have some things up here. You probably won't have stuff up here. And hopefully everyone has downloaded Docker desktop, which is useful. And for those of us on Macs, the Docker desktop runs a Linux virtual machine because Docker has to run in proper Linux. Mac OS X changes a lot of stuff. For those of us on Windows, excuse me, WSL2 already is a virtual machine running Linux, and Docker desktop sort of hooks into that. And I just want to see if folks are curious about anything before we keep on rolling. Cool. Let's take a look at a full stack app that's already been Dockerized. And I'm going to go ahead and put this link in the Zoom chat. And I would like everyone to clone this. So in some directory that you don't mind messing around in.
Set a 7-minute timer.
I'm sorry?
Oh,
I think
Juan's mic is hot.
hot mic. Go
Okay,
ahead
send my
and clone this repo. And this was actually written by an awesome instructor in the evening and weekend program, Chad Mowbray, who was the lead instructor there for a bunch of years until he finally was like, I need more time because I have a full-time job as well, and I need to spend time with my family. And so I kind of pulled this from there. I'm going to very briefly walk through some of the code. We're going to look at it on GitHub. but the main thing we're going to do is run the Docker commands. Um, can everyone see this font size okay? Awesome. So we're gonna, when you Dockerize a full stack app, you're basically gonna break it into three directories: back end, front end, both of which I think are pretty intuitive, and you guys probably did this already with your personal projects and your group projects. And then there's web server. And the web server is where that Nginx web server goes. And this is really about thinking now about a production environment because we can't use the dev server to host our React app. Um, if we really wanted to, we could actually use Django to do everything, but it's very common to separate your API from the server that hosts the front end application because the API, it could be used by a mobile app as well. It could be used by multiple different web apps depending on how big the API is. Um, and so there's just a lot of different considerations that end up making it useful to have a web server whose only job is to host the React app or the whatever the front end site is, whether it's an HTML page or anything else. Um, there's some shell scripts here that we're gonna not talk about too much today. We'll look at them a little bit. There are these Docker compose files. I'll show you all what they are, but we're not going to worry about them too much today. Um, my main goal is just for us to be familiar enough with this app so that we're comfortable with it. And so let's poke around the back end a bit. And this is a Django app like we've seen before. Note, by the way, there's a Docker file here. So the convention is, we'll talk about Dockerfiles later, but usually they're just named Dockerfile and you put them in the directory of the part of the system that we care about, right? And to very briefly hop back to my other diagram, if I can just make my annotator go away for a second or not be quite so intrusive. Where's the one I want? Yeah, this one will do. Those three directories, backend, front end, web server, correspond not quite the same. Note that like we don't have a directory for the database because there's actually not a ton of extra stuff we need to do with Postgres that ends up being put in the backend directory. But this is how we organize our directory project structure for these containers that are going to then compose our system. And so the back end, sorry, I have this open in a couple places. This is a very simple app. The goal is it's on the front end, you see a list of wines. The wines have names and prices and descriptions and stuff, and you can add a wine to the list of wines. And that's all it does. That's the only model. And in fact, if we go in here to look at views, we can see that's the only view is a wines view. And if we go to URLs PY, which is always a good place to start with the Django app, we see this is really the only routing is to look at wines. And if we look at URLs PY for our whole Django application, we see it's just got that one wine API. And if we look at the front end, it's pretty straightforward. Um, a list of wines, you can add a wine. So React Router is done a little differently here. It's not with a router like .js file that's an array. It's done component style. So this is our React routing right here. And there's really only two front end routes, all wines and create. And I think that's enough because I think I want to just now run and install this. So please do code along with me. Hopefully you've already cloned this. Um, let's just run this and kind of watch Docker in action, and then we can talk a bit about what it did, and then we'll play around some. So I'm going to navigate into the directory for the project. And there's all these shell scripts, and we're going to use the shell script to run Docker for the dev environment, run compose dev. We're going to learn about Docker compose later, but in essence, it's a way to simplify certain things and help multiple containers work together. And let's take a real brief look just so we have a little bit of context and we can orient ourselves. So we're not going to dive too deep into this, and I'm going to make this font size just a bit smaller. Docker compose dev file. Note here under services, API, Nginx, database, Django backend, Postgres, web server. We saw sort of a preview of port mapping when I used the Nginx Docker container. We did that with a command line argument. Here we're mapping ports as well to expose ports. We've talked a little bit about Docker images, like a pre-built application environment. And you can see here's a Postgres image. We're going to actually build our own images for the Django backend and the web server. We'll learn about that later, but we can see here a reference to a Dockerfile. And here we see a bunch of environment variables, and these should look really familiar because these are all from Django and settings py. And we're kind of looking at the final product, but over the next couple days, we'll kind of learn how to handle these environment variables in stages. Note that the Docker compose file is grabbing the environment variables from somewhere else. It expects them to already exist. The same way that if on the command line I do to create a shell environment variable, when I use it, I put a $ in front of it, right? So Docker Compose expects the shell environment to already have some environment variables. And so does Postgres as well, right? And these should look familiar a bit from earlier this week, and also just from working with Postgres and Django more generally. We'll kind of dig more into the Docker file later. There's also a volume here for Postgres to save stuff. But I just wanted to kind of orient ourselves a bit. And now let's look at the shell script to run this Docker compose file. Because what this Docker compose file does is it lets us spin up 3 containers to start our whole system in one go with one command. There's some ins and outs. It's important to make sure the database starts first, for example, but we'll get into all that later. So let's look at the shell script that we use to run this compose file. And it would help if I had typed that right. So let's try typing that one more time. And there it is. And the reason we use a shell script is to manage environment variables and make it easier to run this. And again, imagine a team of 7. Imagine we might be using these shell scripts in different cloud environments on different remote servers. So it's kind of nice to bundle it up into a shell script where I can define things. And then, if I'm doing this all the time, maybe like my shell script, I set different values and just don't check it into version control or something like that. But this way, the whole team has a shell script that they can run. And if nothing else, they know what environment variables they need. For some of them, maybe we need to set them a different way with a .env file. or like a extra bit that doesn't get checked into version control, but everything is here. So I don't have to remember all these command line arguments. So export is just another way of saying create, like uh, in the shell environment, right? In the shell that's running in Linux. Export is if I want to like in a shell script create a variable how I do it. And then we create those environment variables and then we run this Docker compose command. Um, the key thing here is this build argument that will build Docker images from those Docker files and stuff, which we'll see later. Here's a bit that makes sure that Postgres starts before Django, because if Django started first, then it would be a problem. So we just have to wait to make sure Postgres is up and running. And note here, we're making migrations and applying migrations for Django. So again, it's nice to have this shell script that does all this stuff. I've been doing a lot of talking. The next step here is to actually run this and watch our whole application spin up. But I do want to check in and see if folks have questions. If there's something you're curious about, or like if there's a part of this that was like absolutely Greek to you, please let me know. Because I do want us to have enough of an overview so that when we run this command, it's not a complete mystery. Owen, yes, sir.
So will this be making a database on everybody's machine when we run this, or is it going to be pulling from the same database from a remote, whatever
Yeah,
location?
great question. Database on everyone's machine. And actually, to be even more specific, when we run this, let me get rid of the annotator now. Now I named these differently than it's named in that app. But when we run this on everyone's machine, it's going to create 3 different Docker images and use a container to run each of those images. And each image has its own little Linux operating system and stuff installed on it. So you'll have 3 different Linuxes, one that has Postgres, one that has Django, one that has the Nginx web server. Does that make sense?
Yeah.
Awesome. Does that make sense to other folks as well? Like 3 tiny lightweight virtual machines, each of which has a different piece of our full stack app. Jacob, yes, sir.
Yeah, I just had a question. I know you probably went over it, but just to
Please.
repeat it.
Yeah.
So like you have like the image for Django and Postgres and Nginx. So Nginx is doing what again? And does that
Yeah.
include like the front end stuff too?
Yeah. Yeah. Great question. So Nginx is our web server. When you guys run npm run dev when you're doing front end work, and then you can go to localhost, what is it, like 5173 or whatever the port is.
Yeah.
So that npm run dev command runs a little JavaScript web server program. And a web server is just a fancy name for a program that takes an HTTP request, finds a file, and sends it back in the response. And that file is usually an HTML file, right? That's all that a web server does. And back in the day, before React and all this stuff, there were no like front end single page apps. And so, all the different URLs in the browser mapped to how things were organized with the different HTML files and the file system on the server. And it's all different now, but that's the essence of what a web server does. Um, the V dev server does a lot of cool stuff for us. It does something called hot reloading, where when I change my React.js code, like lo and behold, I see that happen suddenly in the browser. Um, it's actually using something called WebSockets under the hood to do that, to maintain a constant connection. It does a lot of other stuff that's great for development and debugging, but not so great, when like Nordstrom's or Amazon is ready to deploy this thing live. Um, it's really normal to use a program like Nginx that's a dedicated web server to be the web server for the React app. And in fact, let me go ahead and show that bit because we've seen that a little, not a lot. Let me go into the front end directory. And so we have, what we're used to with a front end app. If we look in source, there's all the different things. We got the vconfig file. We're used to npm run dev. But for production, I'm going to run npm run build, which is, you can look at what the script does in package JSON, but let's run it and see what it does. And I didn't run npm install, that would help. And you all might as well do this. This is totally fine. It's safe. You can run npm install. How many people have not run npm run build before? And I don't think we've covered it a lot in class, so I just want to check in with folks. My guess is at least a couple people are unfamiliar with this. Yeah, I see at least 3 or 4 hands. Again, we haven't needed to. It gets into some complexities with modern JavaScript and what's called transpiling. All that JSX syntax when you're writing React.js code with the angle brackets that makes it really easy to work with it and where it looks like HTML, that's actually not valid JavaScript at all. It actually gets turned into quote unquote normal looking JS before it gets sent to the browser. But browser dev tools these days are so good that you can kind of see the original source. So modern JavaScript, it's called transpiling. We don't compile JavaScript to like assembly language from one language to another. We transpile this kind of special JavaScript with JSX into plain normal JavaScript. This build step also does stuff called like minifying. All the variable names are renamed to be as short as possible, and like white space and stuff is gotten rid of to make the file as small as possible for sending over the web, because that matters. If we're Facebook, we want our JavaScript files that are sent to people all over the world, often going on Facebook on their phones and not having great internet connections, to be as small as possible. The build step does a bunch of other stuff as well. It bundles up all the CSS, all the image assets like into one spot, and it puts it in this directory named dist, which is short for distribution. And so now you all should have a dist directory if you've run npm run build, which I do recommend running. And let's go in there real quick and just see what's in there. So there's another index.html. Our image asset is in there, and there's this assets directory. And I would code along with what I'm doing here as well. And let's look what's inside that assets directory with ls assets. And let's look at these files real quick. Let's look at index.html. And this is a pretty normal looking HTML file, but look at these JavaScript files. The script, it does not say main.jsx, it says /assets, which is relative to where index.html is in our dist directory, because this is all getting served by a web server. So when this HTML file loads, it then tells the web server, go get this script that lives in the assets directory near where the HTML file, live, and this automatically generated name and this CSS file. And then div ID root that we've come to expect from our React apps. And if we look at these intriguing sort of index files, we're going to see they're not very human friendly. So let's do code assets. Yours are going to be named a little different, but just open up the JavaScript file. So this is transpiled JavaScript. This is, at the end of the day, the code that's actually executed in the browser that runs our React app. Though when we do it in dev mode, it doesn't minify the JavaScript. It doesn't make all the variable names shorter. For front end, that's a big development versus production difference. We haven't talked a lot about it because frankly, there's enough complexity on the front end already. But that's something very good to note and remember that like for production, you want to minify your JavaScript and do all these things to make it small. The vconfig file, by the way, is where a lot of this magic happens. If you dig into here, you'll see all these crazy configurations that you can do for this. There's also things where it's smart about not loading everything all at once and a bunch of other stuff. And the React.js sources here, everything we installed with npm install that lives in node modules that our application uses is in this file. All our JavaScript is in here. As you can see, these variable names have gotten like very short and very small. And if I look in here somewhere, I'll find React components. Like if we do, it's going to be what React dot. So note that there's React dot element. Note that they are using JavaScript symbols and naming them to these crazy short things. FF is React dot fragment, so that they can just make the actual size of this text file as small as possible. And this isn't really meant to be read by humans, but that's what this npm run build step generates. Similarly, there's one for the CSS as well, where again, white space has gotten rid of, all the stuff that makes this human friendly is gotten rid of, and the entire CSS for our application from all the different CSS files we might have is put in one file on one line. So for production, we would run npm run build, and then we have here the build of our front end app in this dist or distribution directory. And now we need a web server program to serve this to the browser. There's different ones you can use. Nginx is a very common one that gets used. You can do it with Django. You can do it with JavaScript. Apache web server used to be popular, but Nginx is a pretty great tool and it does a bunch of other things as well. So I know this was a bit of a tangent, but a necessary one. And I just want to check in and see what's on people's minds, like what might be good to dig in about this or discuss, because I realize that I just threw a lot of information out there that technically speaking is not directly related to Docker at all. But important, as your point, Jacob, so now when we look at this diagram with our web server, we understand what this means. And we know that when we create this Docker image, it needs to have everything in that dist directory in there. And when I change my front end app, I would have to build a new Docker image with the updated build. I'd have to run npm run build again and put it in the dist directory. And in fact, if we poke around in the Docker file for the front end, and it's going to be in the web server probably. So let's look in web server Docker file. There's a lot going on here that's pretty complex. We may not build something quite this complex, but we see we're going to create a Docker image. We're going to use an existing one, an official Node.js Docker image. We're not going to worry about what builder means right now. We're telling Docker, hey, find the front end directory on my file system, work from there. These are environment variables for a React app that should look familiar. Note this is set to localhost. This will have to change for production. The URL is from an environment variable because this might be in different places. And check it out. We're copying package.json. We're running npm install. This is exactly like the same commands we could do on the command line. And then we run npm run build. And then further down here, without worrying too much about this extra step, basically what we do here is, because we don't care about, all we care about is what's in that dist directory. Once we've built it, we copy it over and we get rid of everything else. So we have this copy command here that grabs that dist directory. It copies it into the directory in Nginx, where Nginx looks for HTML files. And then we tell Docker, okay, cool. I actually don't need Node.js. I don't need all the source code. You can get rid of that. All I want in my Docker image is Nginx and these files. I realize I totally did go down the rabbit hole here, and this is a bit more advanced, but I do want to ask now, when we look at this diagram and we see these three Docker containers and images, does it make a little more sense about what this Nginx web server is doing and why?
Yeah, at least for me, it makes a lot more sense. I appreciate it.
Totally. Yeah, great question. And that's why I really appreciate it when you guys ask, because this stuff is so complex. It's just so easy to make assumptions about things. And, there's a lot of things where we have to be strategic in what we show and when. So it's really important to get that feedback. And in that vein, what else is on people's minds? What other questions do folks have around this front end stuff and the npm run build and things like that? Are people feeling, how are people feeling, like on a scale of like 10 to 20? Are we at like an 11 or maybe like a 15 or even maybe a 16?
I have a question. Just after hearing all of this so far this morning, my question is like, what's the point of Dockerizing all of this when you can still work on it just from your machine?
Yeah.
Because like even if this is, say you put all of your Postgres that are tables into an AWS bucket and everything can be accessed like online, like what's the point of Dockerizing it so you can work on it compared to like just cloning it and then working off of the Django server and the Vite server?
Yeah, great question. Like, why do we need to do all this work?
Yeah.
And you raise a really good point about the database. So let me tackle this in two parts. Let's talk about the database, and then we'll come to the whole piece. So you raised a really good point. It's like, hey, why do I need like a whole tiny lightweight Linux virtual machine running Postgres when we could just have one Postgres on AWS in the cloud that everyone's using? So companies do this to kind of zoom out of this diagram and hop back over to this other one. And let me get rid of the annotator. In a staging environment on the AWS, we might have a bunch of old data or like real data that's just like 2 weeks or 3 weeks behind. And maybe all the different developers working from the local dev can interact with this. But there are a couple issues. One is if we have 5 or 6 different people interacting with this database, it's constantly changing, right? It's constantly changing. And if I'm working on a big, hefty feature that takes me, even one that takes me like a couple hours, much less a couple days, I kind of need my data to be exactly the same and not suddenly be changing for reasons unrelated to my code and what I'm doing, because it'd be really difficult to do work. Because as you all have discovered, there's this workflow of I write a little code, I run it, and then I might have to go into Postgres to see if like my Django model correctly did something in there. And you're kind of depending on having consistent data as you develop to help you develop and debug productively. So you really don't want like 5 different people messing with a database that you're kind of using for your feature. Um, and also depending on how many steps are involved with the database, depending on stuff we haven't talked about, like if we have to like have like database clusters, um, just going over the internet might just take more time. So it's really nice to have a database running on your machine, like we've had in the course, where you can control everything, right? And put in exactly the data you want. Also for running automated tests. As testing gets fancier, the test suite often creates its own database that it puts the test data in so that you have consistency when the tests run. So it's really, really nice for local dev to have a local database. What you do see sometimes is like if I'm working on a big feature, um, when I worked at reverb.com, there were like what 20 engineers and I think like 2 or 3 staging environments. And if you were working on a key feature, you might like claim the staging environment for a week so that you could have your code in a more real cloud environment and push it up there every now and then to test stuff out. So you might have different people sort of claiming different staging environments for various periods of time where it's just sort of someone sends a Slack message and it's like, no one touch this, please. Um, Development aside, we also have to think about deploying the actual application to production. And that's where doing all this work is also useful because once I'm ready, I've written the cool new feature for Amazon and it's ready to go live. I need to put it on the production environment in the cloud. And I don't actually want it to change easily. I want that to be a very controlled process. I want the build to be a specific file with a specific name. Like you might even like when you deploy to production, like a whole feature might be condensed into like a single commit. Because then in the production environment, if you have a problem and you need to roll back, you just need to roll back like one commit. So it really depends. But the production piece is why we want to Dockerize this stuff because the job of this Nginx Docker container is not really to help me with local dev. It's for deploying to production, but it's also so that as I develop, I can have a sort of mini production environment on my laptop because there's all these ins and outs, with environment variables, port names, URLs, file paths. There's a lot of ways for stuff to break. So it's really, really nice once I've developed my feature to be able to spin up my own miniature production environment that's almost but not quite the same as the real production cloud environment on my laptop and make sure everything works. So that was a long answer to a short question, but did that help kind of illustrate things a bit more?
Yeah, a little bit.
Yeah. Does it still kind of feel like, hey, this is a lot of stuff?
Yeah, it's my whole, I guess, belief of I kind of know what I'm doing just went down the gutter now.
Yeah. So you've
Welcome to my
had,
world.
yeah, I'm glad you said that. That's okay. That's normal. To be honest, I felt the exact same way when I first encountered this stuff, which for me happened a little bit kind of reading about it, but really when I got my first like engineering gig, it wasn't even like I worked for a couple places that were small, but I've mentioned reverb.com a couple times. That was the first place where I worked and got what's called production experience. And I had like 3 or 4 years of experience like building things for real, but like they were tiny. Maybe they had hundreds of users. You know, Reverb is, and they actually, this is a different story, but I was actually let go from there after about 9 months, which was in part, it was a bad fit. In part, it turns out you can't be a developer there if you're living on 4 hours of sleep. And I tried to a bunch of things. It was a tough team I was on. I tried to learn Ruby on the job. But so this is an e-commerce store for buying and selling music gear. I don't know how many daily users they have. It's clearly in the thousands. About 6 months after I was let go, they got acquired by Etsy. Um, so I had never had production experience before. I had never encountered any of this stuff. And it's a lot. It's 1000% overwhelming. Um, think of this more as like a preview. Um, the Docker is useful, and every company does it differently, so it depends where you work. Um, but the same way that the OOP assessment, I think, was a big step forward for you all in terms of program complexity. And then the personal project was in terms of program complexity and project complexity and sort of system complexity. This would be that next step forward too. And this is more of a preview of it. Like you don't have to be 100% on all this stuff. It is overwhelming. It's a big part of why, as a junior engineer, when you join a team, you're not really expected to be productive for 3 to 6 months. The team is really making a 3 to 6 month mentorship investment in you. And then around month 6, you spin up. And even an experienced software engineer, if I joined or any of us joined Google tomorrow, we could be wizards, but they have a massive planetary scale cloud computing system. There's no way I could be productive for at least 6 months or something like that. So there's a ramp up speed with all this stuff. This is also why, like, getting production experience is so valued in the industry because then you start to learn about these things, right? And it's kind of hard to learn about it without having done it for real. And even working somewhere small where you actually deploy like a basic web app live, there's all these ins and outs that happen. So any experience that involves like real users or real problems is worth its weight in gold and can go on your resume. So it's totally okay that this feels like a lot right now. Um, the big picture of all these things we can worry about a bit less. I think the main takeaway I want to push is code gets run in a lot of different environments, right? We've just been running it on our laptop, one person's laptop. With the group project, you've got 4 or 5 people's laptops. That alone causes a lot of pain points. Once you start introducing like cloud and like different cloud environments, it adds even more. The same way that with Django, it's great that I can run pip install and it looks at requirements.txt and it installs the exact versions of the stuff I want. Docker is like that for a whole operating system, for a whole virtual machine that I can, in one command, have a whole application environment with my code exactly how I want it. And sometimes we use that for development, and sometimes, like with Nginx and this npm run build step, we use it for production. And so it's useful to be able to simulate that production environment on my laptop too, and we use Docker for that as well. Does that help a bit break it down more, Owen? Yeah. Great. Oh, sorry. Go ahead.
I was just saying, yeah.
Cool. Yeah, great question. Again, thank you for saying that you're not alone and feeling like it's a lot. And it is a lot, and that's okay. And this is also like we haven't talked about system design or anything like that in this course, and that's a little more advanced. No one's expecting you to really know all this stuff. No one's gonna be grilling you on this in the interview process. But Docker has become really common, especially for local dev environments. So being able to be familiar with it will help you on the job. And being able to like add it a bit to a personal project will look really good on your resume. And frankly, Chad, who created this, he's a data engineer by profession, They deal with like the pipelines for all the training data for machine learning systems, for example. They deal with huge amounts of data like moving through cloud environments and backend systems. So he lives and breathes this stuff. And that repo that I was showing you guys, that's like a real world production setup, which is why there's all these layers. But you guys don't need as many layers just to get started. I saw another hand up as well in the Zoom, so I just wanted to check in.
No, you kind of already mentioned what I was gonna say to Owen and everybody else was re- Docker is pretty much just like a requirements TXT, but on a bigger scale. So just look at learning the concepts of Docker and then look at it as a requirements TXT. You're just putting it in AWS or GCP or some other server to run your application, your entire environment.
Yeah, I think that's a perfect way to put it, Demi. Like 1000%. And in fact, if we look at, I think the Django Docker file might be easier. Here's the Docker file for Django. Just like you were saying, Demi, this is a requirements TXT for a whole application
I
environment.
sound like Demi.
Oh,
No.
James, I'm so sorry. No, you didn't. My brain is just in too many places. Um, yeah, you hit the nail on the head. This is our requirements.txt. We start with a Docker image that has Python, a specific version, and this one already has Linux. Yeah, James, again, I apologize. That was totally my bad. Um, we copy the requirements.txt over, we run it, and then we run this command to Unicorn that's not worth going into in a moment, but it starts up Django with a little bit extra. And this is where we're going to end up. I realize that we've sucked up the whole hour and we haven't even written a lot of code yet. So, what do y'all think? Should we take a short break and then spend like 20 minutes coding along to do some Docker stuff? Does that sound good?
Yeah, that sounds good.
Okay. I realize I'm eating into the morning, so I appreciate it. I think this was useful though. Because there's a lot here where like this touches on a lot of stuff we haven't really seen or delved into yet. Um, and I want to make sure like you guys have the tools to like understand this stuff. Um, and like as you can see, and James, like you were saying, this Docker file, it's like a requirements.txt to build a little virtual machine. And the magic is here in this from statement right here, because this is a whole other Docker image somewhere else that kind of has its own Docker file and requirements.txt. And the same way Git commits kind of stack on top of each other, Docker images, you kind of can stack them on top of each other too. And it gets a little inception-y. And so someone has already done the hard work of making a Linux system with Python version 3.11. And now we can make sure that not only does our Django code have the same version of all its dependencies, but it runs on exactly the version of Python I want, in exactly the operating system I want, with exactly the same setup, exactly the same way, anytime, not just on my laptop, but on your laptops and the rest of the team and in the cloud as well. So why don't we take, should we do 10? I've been going for an hour here, so I think 10-minute break sound good?
Yeah,
Yes.
that sounds good.
Yeah, let's take 10 and then we'll circle back. Now that we've seen all this big picture stuff, we're just gonna do a little coding along to like play with running Docker containers and we'll build a couple images of our own. Thank you guys very much. Great questions. Please keep them coming. Have a good break, and I will see you all in 10 minutes. And let me go ahead and pause that recording. Okay. So we've done a big review of why Docker. We've also done a relatively deep dive into a full stack productionized Docker app or web app. Let's actually run this. So hopefully everyone's cloned down this Docker Compose app, this wine app, and we're gonna run this run compose dev shell script that again is running these three services. It's creating three little virtual machines, one for our API backend, one for our web server to host the front end, one for the Postgres database, and it's telling our actual computer to save some space on the file system for Postgres. So when we stop and restart this thing, that we keep our data. And you can just go ahead and type // to run the shell script and run compose dev.sh. And it's going to take a minute. It's doing a lot of things. It's pulling down Docker images from Docker Hub. It's pulling down the Postgres image from Docker Hub. For Nginx, it's pulling down the Nginx image from Docker Hub and going through all the different things in that Docker file to build a Docker image, to build this tiny virtual machine, this tiny Linux machine for our web server. And it's going to do the same thing for our Django backend. It might take you guys longer if these images haven't been pulled down before. James, yes, sir.
Can you show the command that you ran again to start all that?
Yeah,
Scroll up
absolutely.
under.
So you want to be in the root directory of the project. If you type ls, you should see this shell script in that same directory. And then to run it, you can just do / and the name of the shell script, run compose dev.sh. And that, like, a shell script is just a bunch of stuff you could type on the command line. The shell, bash or zsh, actually has its own tiny little programming language, along with all these little programs that we use. And that's actually what we're doing when we do stuff on the command line. Owen, yes, sir.
On line 12 in the run compose dev.sh, my terminal saying the command is not found for Docker compose. Or wait, you did.
Is anyone else getting that same issue?
Or was I supposed to do the Docker compose? Because you're looking at the .yml file, correct?
Yes, but you are supposed to run the shell script. That's correct.
So that line number 12 is giving me issues.
Oh, I see.
Is it? I'm assuming I don't have some dependencies.
Maybe I don't think this is necessary, but I should have. I totally forgot, folks. You might as well run this command docker login as well. That we need to authenticate our Docker program running on the command line with our Docker Hub account. So I do apologize. Please go ahead and run Docker login. Also, please make sure you have the Docker desktop app running as well. This does need to be running. I don't know if that's going to resolve it, Owen, but give those a shot and
that didn't resolve it, but do I need to put those images in my Docker desktop? Because I do have it running.
Yeah, you do not. It should automatically pull down those images if you don't have them.
Okay, yeah, it's.
Can you share your screen and show me the error? And while you're doing that, Can I just get a quick show of hands from people who got this, ran the shell script successfully and saw this message here that these containers got started? Can I just see some hands up for people who's who who ran the script successfully and it says the containers were started?
My script seems to be running successfully. It just haven't completed to that point where you're at, where it's
Got
saying
it.
that it's running, but it's going through the motions.
Awesome. Yeah, it may take a while because it is the Docker images can get big, like 500 megabytes. And it has the build stuff, so it may take a minute. Um, anyone else have it working successfully, or is it still in progress?
Mine gave me an error. It did a lot of the loading up stuff, and then it said failed to solve, deadline
Okay,
exceeded.
got it. Okay, let's tackle this one at a time then. Oh, and do me a quick favor, just type ls. I know we're there, but that's just always how I orient myself. Error response from Damon, no such container, Docker Compose app, API 1. Oh, this may just be,
Oh yeah, I got those messages too, along with mine.
okay. I think I know the issue here. Oh, and go to the Docker Compose dev file for me, please.
Which one?
Docker compose.dev.yml.yaml. Yeah, there might be a different branch of this we can check out. I think we just have a misnaming. Let's see here. Docker exec, Docker compose, app, API 1. Let's see, Docker compose dev, line 12, Docker compose command not found. Okay, let me actually Google that real quick because I'm a little surprised. But maybe there's just a step
You
missing.
might not have the Docker Compose plugin. You might have to install the Docker Compose plugin.
Did you have to install that as a separate step?
I didn't, but some of uh, the material says that it doesn't always install on everybody's machine, so you may have to do it separately.
So you're saying install this extension, or what are you saying to install, James?
Stand by. I put it in the chat real quick.
Yeah, I think you might be right. Um, because I did a quick Google that took me to the Docker doc saying something similar. Owen and Jacob, are you guys both on Mac?
No, I'm on Linux.
I'm on Windows.
You're on
That's
Linux as well?
disregard what I just put in there. That's only for Mac users. I thought you was
Oh,
on Mac.
okay. No, I'm not on Mac.
All right, let me delete that.
Is this, James, are you looking at the docs.docker/compose/install page?
Yes.
Yeah,
Yeah.
I'm looking at the same thing. Good call. Yeah, it's got the Linux plugin. It's got steps there as well. Um, let me just share my screen. Uh, yeah,
Okay.
James, thank you. I think you hit I think you hit the nail on the head. And this caught me by surprise. Great example of why Docker exists, right? So Owen and Jacob on Linux run. Can you guys see this okay?
Yeah.
Sudo
Yeah.
run, apt-get update, sudo apt-get update, and then sudo apt-get install docker-compose-plugin. And while you guys are doing that, Did anyone else have an error or run into something unexpected? James, yes, sir.
My I got an error when it tried to run just a pip install with the requirements txt.
What
That
was the
makes
error again?
sense. Error API 4 out of 5, run pip install requirements txt.
Okay, we might have to look at that in a minute.
Okay.
Owen and Jacob, can you guys, once this is installed, run it again?
Yeah, I'm still getting the same error. I still get the run compose dev sh line 12 docker compose command not found error response from daemon message no such container docker compose API one.
Run. Let's make sure Docker Compose was installed. If you guys do Docker dash compose space version on the command line, what do you get? Or Docker space compose version? Because you might just have to like reopen a shell.
Docker compose version v2.31.0 desktop 0.2.
Okay, interesting. And you still get the same. It still says Docker compose and Docker dash compose
That does not work. So maybe I had to do this Docker space compose version.
And if you do Docker dash compose,
I get command not found.
okay, got it. I wonder if this is an issue with different. I have no idea why they would ever have it be two
So I'll
ways, but
probably have a future version.
yeah, let's see. Update, install. I don't know if we want to symlink it. I think honestly, for the moment, I think the lazy solution, and this is just for Owen and Jacob, if you're running into the same issue, in that run compose dev file, just change that command in the shell script to be Docker space compose, since that seems to be how it's installed, and let's see if that does it.
It's starting to run.
All right, nice. Yeah, the better solution is to make an alias and add it to your ZSHRC config file so that the same way we did aliasing Python 3 to Python back in InstallFest to alias Docker dash compose to Docker compose. Which would look something like, where did we, there we go. So you would just type, I think, alias space Docker dash compose equals, and then in quotes, Docker space compose. And I'll go ahead, I'll put that in the Zoom chat. All right, and now let's tackle James Cromer. Were you saying you had an issue as well?
Yep. I can share my screen.
Yeah, let me unshare. Let's go ahead and see your screen.
Possibly I'm not sure if I missed a step accidentally too. Because I fell behind at one point. It gave me this error when it was running.
Can
But it
you
actually
scroll
is
up?
giving me this down here too. I can scroll up.
Yeah, I'm getting that now too.
Now, can you go back to the error, please? Up just a touch so we can see it. Let's see here. Error API 4.5 run pip install R requirements canceled. Run pip install downloading error could not find a version that satisfies. Okay, so it looks like the relevant bit is towards the bottom where it says Air could not find a version that satisfies the requirement. Install 1.3.5. So it looks like this might be an issue in the requirements.txt, which I'm a little surprised by because I think this worked for me. And let me make sure I'm on the same branch as everyone. I'm on the main branch. Can I just get a confirmation? Did this work for anyone? Can I get a hands up from people that this worked for without error? So this failed for everyone. Is that right? Am I getting that right? Okay, I did ask that like 3 times, so I just, folks, I kind of like we can't get this working if we don't communicate this. What errors are people seeing? Are people seeing this same error that James Cromer is seeing? Or are you getting other errors?
Yeah, mine was similar to, it was kind of like a mix of Owen's and James's because it's saying I had like the same error messages at the bottom as Owen, but also as James. So it is giving me something about the same thing, the requirements.txt. Yeah, so and then it says that I get the error response from Damon, no such container. Um, and then also it looks like it's having a problem building the service API. Service Engine X says built, but my service API, it keeps trying to build that, and then it sits there for like a minute when I'm trying to like load it up, and then it just says it failed. So it never got to build the service API, it looks like.
Got it.
So I'm not sure, but yeah, I am getting very similar stuff as James there.
Okay. Interesting. Okay, because I just stopped mine, deleted the Docker images in case they were being saved. Huh. And ran the shell scripts again, and it seemed to work. Okay. So and James Cromer, are you on Mac, Windows, or OS X or
I'm
Linux?
on Mac.
On Mac?
Hmm.
Okay. Um, who else is getting the same error as James Cromer? Can I just see a show of hands?
I have the same exact one. Yeah.
Oh, and Haley, Jacob, you mentioned something similar. Um, Sean, what about yourself?
Yeah, I don't even have it up running. The old Docker file was empty for me on GitHub.
I'm sorry.
The Docker file on GitHub was empty. I don't even have the repo available.
Okay, I'll circle back to that one. Demi, what about yourself?
Negative, Ghost Rider.
Same issue or different?
Uh, Same.
Okay, cool. Thank you. All right, then it sounds like if we can get this one working, it'll help a bunch of folks. Error no matching distribution found for install 135. James Cromer, do me a favor in the backend directory, open up the requirements.txt. Let's just take a look at it. Open up the Docker file in the backend as well. Let's see what. Oh, so I wonder if this is. I have to admit I'm a little boggled here because I feel like this is. I just spent an hour talking about how Docker solves this problem, and yet we continue to run into it, which only goes to show how complicated this is. Because in theory, we're all building off of the exact same. Do me a favor, James. As long as we're here, in the command line, type Docker space PS for me. Let's make sure nothing's running. Okay, do Docker space PS space -A to show any stopped containers. -A. Yeah, exactly. Okay, type Docker space images, and this will list all the Docker images that we have. So it built the Postgres image. Let's delete that. Type Docker space RMI for remove image space. Um, uh, you're gonna want to just copy and paste that image ID, I think, in after. Yeah. And go ahead and hit enter. And what we'll do, folks, I thought this would be a quick one and done. If this doesn't work, we'll switch gears. We'll do some other stuff. Let's run this again. Just go ahead and run that dev shell script for me. Yeah, thank you. And let's just watch this go from the top. But we'll probably see the same error, but yeah, so we got far. We copy requirements.txt, run pip install R requirements. That
It
isn't.
look like it's that install equals 1.3.5 file because I got that same error as well.
Yeah, I'm kind of confused on that one as well. Because if we in the requirements.txt, if you open it up, I don't think there's a dependency like named install. Um, oh, there is. There it is. Install 1.3.5. Okay. Okay, James, good call because I missed that the first time around. So the let me make sure that I have that same thing in my requirements.txt that for some reason I haven't diverged. So yeah, the crazy thing is I have that same thing. Let's see what that is. Hover over that where it says install in VS Code, James. Yeah, click on the link. Let's see this on PyPy. Let's see what the heck this is. Yeah, just yeah, try typing install. I'm gonna use ChatGPT or Claude AI to ask like what Python package this is. Um, yeah, I wonder if install just doesn't exist. Though what really boggles me is why did this work for me and fail for everyone else? Um, I'm gonna just Google this as well and see what. Okay, let me share my screen real quick. I may have found the solution. Why the the issue it works for me is a bit of a mystery. Just to show you guys, just so people know that like I'm not losing my mind. Um, I have the exact same thing in the requirements.txt. I deleted all the images and I ran it and it worked. So clearly there's something different on my system. And I didn't change any files. So I don't know what is causing the difference. But when I Google pip install 1.3.5, which is probably the first thing we should have done, lo and behold, this second result here says, please change install equals 135 to pip install, package install not found. I have no idea. This must be for installing stuff with pip. I have no idea why this worked for me and not other people, though it clearly failed for a lot folks. So let's see, I'm gonna try it now and run it, and I'm gonna stop the containers. And if you guys want to do the same thing and just change line 6 to be pip dash install. And in fact, I'll commit that change to the repo. And let's see, this issue was only created on July of this year, so this is relatively new. Welcome. I know I already said welcome to software engineering, but welcome to software engineering. This is why AI can get pretty good, but it can't solve this problem. So
I think it's working for me now for what it's, yes, it worked.
all right.
I was
So
gonna say that works for me as well.
awesome. Thank you, Haley. The lesson learned here is I should have just Googled that right off the bat. I can't tell you guys how many times I've spent way too long fiddling or trying to figure out an error message when if I had just like Googled the thing or like looked up the relevant part of the docs, I would have figured it out. So if there's a lesson to be learned here, I think that's it. Awesome. Someone else said there was Sean, was it an issue cloning the repo?
Yeah, it's just empty. And I was getting too far behind the lectures, so I just gave up and just started listening.
Got it. Okay. Let's
I mean, if
so
you want to drop a link to it, that'd be helpful.
yeah, I can totally do that. Where is it hiding? It should, yeah, you should have access to it. Okay, I just dumped it in the Zoom chat. Go ahead and git clone it. I wouldn't worry about it too much. Because at this point we took a while, so we're gonna switch gears in a minute and do something that doesn't involve this anyway, but we can finally get a payoff for all of our hard work, which is for those of you now seeing these starting messages, and James, actually or Sean, I'm so sorry. Once you clone it, I'll just kind of repeat the steps. So clone it, navigate into the directory. Are you on a Mac?
Yeah.
Cool. You're going to want to open up backend requirements.txt. Line 6 here, it's going to say install. Change that to pip dash install. And then I'll paste this command in there as well. Run, and this needs to be from the project root directory, run compose dev shell script with that command. And so folks, if you all type Docker PS, do you see these 3 containers running? Awesome. You can see it in Docker desktop too. It'll list this stuff. Container IDs are automatically generated. They're always unique. A container uses an image. We could make a bunch of different containers off of the same image. A container runs an image. The image is the thing that has our like tiny, computer in a box, our virtual machine. So we have the image here for Postgres we built, the one for our Django app, the one for the API. This is the command that it was run with. So once our image is created, this is the command that gets run. This gunicorn command starts up Django. It's called an entry point in Docker. You can't see it here, but this one starts Postgres. This one starts the web server. We can see here the names that we've given them, and then we can see here the ports. And the one we care about is the Nginx web server, because this has the front end app, and it's on port 80. So you all should be able to go to just plain old localhost, or if you want to localhost :80 and hit enter and see this same thing that I'm seeing now. Are people able to see this? It's pretty minimal, but notional navbar. List wines, I have a bunch here. because I've been fiddling with the database. I've been adding stuff. Yours might be empty. If you go to create wine, you can put stuff in there. And when you hit submit, we can open up the network tab and watch, in fact. When I hit, that's not what I want. When I hit submit, if I scroll up a bit so we can see it, our React app makes a post request to localhost / API with our wine data, and it gets saved to our Postgres database. And because we've created a Docker volume for Postgres, that's saved in the file system. So if I use the stop script to stop everything and start them all up again, the stuff I saved in the database would already be there. And we can take a quick look at the stop script. It doesn't do a ton. As you can see, Docker Compose has an up and a down command. And the shell scripts are just there for consistency so that we always use the shell script instead of interacting with Docker Compose directly. And so Owen and Jacob and anyone else on Linux, you may have to tweak this as well. So this was a lot of work, but like, and there was an error in the code. But once we fix all this and get it working, the thing about this is, in theory, my grandmother could install Docker Desktop. She'd have to know how to open up the command line, but just run this one command and have the system running. Everything we did day one install fest, none of that is necessary. Your computer doesn't need to have Python installed. It doesn't need to have, we need Git to get the code. In theory, we only need Git because we're building the images and stuff. But like the whole value of the Docker containers is like we don't need to install Python. Like all of that happens inside the containers and Docker so that this can be run anywhere. In practice, as we've seen, it's shockingly complicated, even the simple stuff. But this gets us closer, and hopefully we saw some of the value of Docker. Hopefully this feels kind of cool that you can run one command and spin up a whole system and have it working. Even though it took us a couple steps to get there. How are folks doing? Are we do we want to break? I know the debugging can kind of take energy, or are we good to go for like another 10, 15 minutes?
Let's just go
I'm
for
good.
another 15 minutes.
Yeah. All right.
I got one question, Adam.
Yeah.
Just to make sure I'm understanding this correctly. So with running that run command, it's the equivalent, I guess you could say, if we're putting it just metaphorically, to npm run dev, running the database, and then on top of that, running the backend with the run server. Because it does all three at the same time, right?
It does all three, and it not only does all three, it like creates images that have all of those things. That we can then like reuse later. I'm getting all these warnings, so I'm stopping the containers. And when that's stopped, the app will stop. But if I hop over here to images, so what I could do now if I wanted to, like for production, I could use Docker push to push these images to Docker Hub, and then I can like SSH into a server in the cloud or run some command to tell the server in the cloud to pull down these images and run them, and it will have the whole application ready to go. So it's not just that it starts all that stuff up, it's actually like created these virtual machines for each of those things.
And then right from there, I can go straight into working, correct?
Say that again?
And then straight from there, I can go right into working because I'm used to the routine now of npm run dev, and then I switch terminals. I go to my backend because I have 3 open in VS Code. I'll run the server, and then I'll go into the other one that when I used to navigate files. Am I right?
Yeah. From here, you can go straight into working. I believe that is correct. If we look at Docker Compose Dev, um, it's it's a little different. The Django stuff, yeah, it gets a little different because so the Django stuff should work. Let's see here. Is there a shared volume? Um, I'm not sure if this Docker Compose dev file is really set up for local development. The issue being, like, if I change the backend code, I don't think this is set up so that those changes are in the container. Which you can set up with Docker with what's called a volume, but I don't think we set it up that way here. I'm not 100%, but sort of for example purposes, like for instance, if I go into, like if we go to localhost and we've got notional navbar, and I'm pretty sure we didn't set this up with the front end stuff. Because I think if we go to front end and we go to Dockerfile, yeah, because I think the way we set it up with the web server, it yeah, it runs the build. So for instance, let's say I want to change something and I do code, front end, source, and let's just go to app JSX. Well, here's notional navbar. Let me just add like 100 exclamation points here and save it. And now normally with local dev, with that Vite dev server running, I would come up here and I'd see it right away. Here, that's not the case because this is not the code on my file system. This is, we ran npm run build and we stuck that build inside the Nginx Docker image. You can set it up for local dev where it shares code with your file system, and people do it that way. And we should maybe modify this, but I think for teaching purposes, we sort of did it this way because it has less steps. Truth be told, on a practical level, for something that's relatively straightforward, that's just a database and Django and React, it's actually easier to do local dev without Docker, like 75% of the time. It's kind of an extra layer. If you start adding more things, like maybe you need Redis for caching, maybe you need some other service that's a job queue. And if you're a big company and you have like 100 engineers, at that point, using Docker for local dev starts to have more value. The way you would use this current setup is once you're done, like use Docker locally to make sure everything works and looks right because you're kind of able to test it out in a production-like environment on your computer. I know that was a long answer to a short question, but does that help answer it a bit?
Kind of, but it just raises another one. Are we gonna get into how this is gonna look? Because of what you have up right now, are we gonna get into how this is gonna look going from starting working, making some changes, making the saves, and showing how that's gonna reflect, like basically from point A to point Z?
Yeah, we can do that right now, in fact. And this workflow is not so much about local development. This is more like we have a new version of this build that like we're ready to push out and deploy. So the dev, there's some differences between compose dev and prod. Really, this is like production light, and the prod one is more about AWS. Like if we look at Docker Compose prod, like there's some differences here with image names because this production Docker Compose is designed to be run from a server in the cloud on AWS. So it's like pulling it from Docker Hub. It's looking for a name of the image that we create. So dev here isn't about like developing, it's about running this on my local development environment. So the answer to your question, so you wouldn't really use this as your developing code, but again, when you're ready and you have like a new version of your build, then you would. And the short answer is, first we make sure everything is stopped. So I'm gonna run the stop script and we'll give it a minute. And we have to rebuild that image because I went ahead and I added all those exclamation points to app.jsx. I added this really important feature right here, right? But I need to get that code into the Docker image. And the way we do it, we don't modify the image, we just make a new one. The same way with like Git commits. You don't modify a Git commit, you just make a new one. And that's kind of the beauty of Docker. And if you all want to, like you can do, we'll worry about Docker push later. But I can go ahead and run compose dev again, and it's going to build these images again. And in fact, if we poke around a bit in our run compose dev shell script, this dash dash build argument right here tells Docker compose, create these images from scratch every time. Without that, it would reuse existing ones, which in a different situation we might want, but for what we're doing here, like where we're building a new version that's going to be ready for production, this is actually what we want. And so now that this is built, if I hop back here, now I see my changes.
Got it. So we're not losing anything that we've already learned. We're just adding to it with Docker.
Exactly. Exactly.
Gotcha.
Yeah. You know, like if again, it's for something that's you know, Postgres, Django, and the React front end feels like a lot, but in another month it'll feel like secondhand. If we had a system with more parts, like Redis for caching and Elasticsearch to power a search engine, and I was a full stack dev, and my system now had the Django API and Postgres and the React front end and Elasticsearch to power a search engine and like Redis for a caching layer. And you know, just to do development work, I had to spin up these 5 things. At that point, we might want to use Docker for local development, and we would configure it differently with volumes so that as I change source code, I would see it reflected in the containers and stuff. What else is on people's minds? What other questions do folks have? Okay, I have one last exercise for us to do. This one actually should be dramatically simpler because we're just going to create a Docker file of our own. So this one is a code along. Go ahead and just stop the system that you're running with the stop script app. And we'll take a minute. And go ahead. I would navigate out of that project directory into a different one. And now what we're going to do is we're going to just play around with the Ubuntu Docker image, and we're going to make a Docker file for it. And so Docker images live on Docker Hub, and we'll see how to push stuff there in a minute. The same, and this is, you know, the same way you can go to the NPM site to search Node.js packages and PyPy for Python packages. There's an official Ubuntu Docker image, though it doesn't have quite as much as you would think, as we're going to see. We're going to install 1 or 2 things. So run Docker space login if you have not already, because we're going to pull from Docker Hub. And Docker will pull down an image automatically if we don't have it. But just for fun, let's do Docker space pull space Ubuntu. And then let's do latest. And what we have here is the name of the image and the tag, just like with Git commits. And if we look here, we see there's different versions of Ubuntu and they're tagged with version names. And so we could do the same thing with our application. You know, I just added that feature of all those exclamation points on the homepage. And so when I build those images, maybe I add a tag with a version number, I push them up to Docker Hub, and then if we were on a server in the cloud, we could pull that down. Docker will grab latest, the most recent version of something by default, but it's not the worst habit to specify the version that we want. And repository does not exist. And it's because I misspelled Ubuntu. And I think I already had this.
Yeah, you go ahead.
So
I just closed
think,
that because Bella kept going in and out of the cabinet.
Jacob,
you
you
got
got
a
a hot
hot
mic.
mic there, Jacob. Okay. Is Ubuntu pulling down for everyone? It might take a minute. Awesome. Again, when you like use a Docker file or a Docker compose or Docker run, if you don't have the image on your computer, Docker will pull it down automatically. So we don't actually need to do this step. I just want to have you guys see the pulling in action. Now go ahead and run, and I'll paste this command in the Zoom chat as well. Docker run, and let me make sure I get my syntax right here. And you guys sort of saw me doing this the other day. And I'm just gonna go ahead and clear this. Docker run dash for a flag. I for interactive, T for terminal. So we want to be able to interact with the shell here. And we're going to give it a name. So 2 dashes and then name, another flag, space, and then the name of our container to make it easier to use. And just name it like UB-1, something short, Ubuntu 1. Docker will create names automatically, and there are things like flamboyant Rosalind. I'm not making that up. That was the name for a Docker container I was using before class. You can also refer to containers by the IDs, but it's easier to have a name that we name. And after this, we tell it what image to use, and we're going to use Ubuntu. I could say Ubuntu latest. I don't need to, it'll grab Ubuntu by default, but we can do it this way just for fun. It would pull it down if we didn't have it already, but we already do. And now everyone should be in Ubuntu. If you type who am I on the command line, it'll say root. So this is on your computer. We've got a Linux virtual machine running Ubuntu on your laptop. And is everyone seeing the same thing that I am and successfully in that Ubuntu? Awesome. So this Ubuntu doesn't have as much stuff as like our Linux that we're used to. For instance, if I want to use Git, it's not installed. So we are gonna install it. Go ahead and run apt-get update. apt-get is the package manager on Linux, and we're gonna get the most recent versions of like the new address book, basically, for all the different packages. And then apt-get install Git. And do you want to continue? We'll hit Y. It's installing 1,000 packages that Git depends on for certain things. And to go back to some questions earlier of why does Docker matter? Well, you know, look how much stuff Git depends on. We did an awful lot in InstallFest, but I don't think installing Git was one of them because it's just kind of on Macs and like the WSL2 Ubuntu, I think, has it already, and Linux already these days. but especially for like Linux servers running in like production environments or cloud environments, or just other differences, there's so much stuff. So being able to recreate like a system exactly is really useful. And now if I do Git, I get this big printout, and that tells me that Git's installed. Was everyone able to successfully install Git? Okay, awesome. Let's go ahead. Yes, James. Yes, sir.
Sorry, I was not able to install Git, but I might have just gotten the commands incorrect.
What error message did you get?
Unable to locate package Git.
Oh, apt-get.
Install or oh, I did get, not get twice.
Well, I misspelled Ubuntu, so you're in good company.
I got it. Thanks.
Yeah, for sure, for sure. Now let's go ahead, just type exit just for fun. We're gonna exit. Now we're back on our machine on the host system. If we type docker ps, we see that there is no running container. If we type docker space ps space -a, we see that we have, there might be other containers, but you'll see the container that we just created. It's not running right now, but it's still there, and it's got our name. If I drag this out a bit, we see over here the name UB-1. And I can go ahead, and now that I've created the container, I don't need to use docker run. I can do docker start UB-1 and hit enter. If I type docker ps, we'll see that it's running right now. The easiest way to interact with this and get the shell is using the attach command, which will just use whatever that container is configured for automatically. And for Ubuntu, it's configured to give us a shell. So we should be able to docker attach space UB1, and now we're back in there. And if you type git and hit enter, you'll see that I still have git that I installed. And go ahead and type exit. So this is great, right? This is useful. Ubuntu now has git. But how can I share this with other people so that not everyone has to go through this manual install step with Git? What I would really like is to create a new image based on this and share it with the world. And push it up to Docker Hub. And let me make sure I have my syntax right here before we do that, but we're about to do that right now. So what we're going to do is, first off, I'm going to type docker ps just to make sure my container is not running. And we're going to do docker build to build a new image. And all that Docker compose stuff and the Docker files, it was using docker build to do this. We're going to do -t to give our image a name. And the name is going to be UB-1 colon, and let's just do V1 for something simple. And this part has to be the name of the container. And then V1. So we've got our container name there, and we're going to do docker build space -t UB-1, and then our tag name is V1 here. And what did I do wrong? I think what I did wrong is I need to, do I need a dot? Yeah, it's looking for a Docker file. I think I need to specify the container name here. Let's see if that does it. No, give me a. Give me a sec here, folks. I apologize. I got my syntax wrong. Let's see if I can get this right. We might need to make a Docker file. I thought there was a way to do this without the Docker file, but I might be wrong. But that's actually okay because we want a Docker file anyway. Because what you really don't want is a Docker image that's a black box and you have no idea what people have put inside it. So let's just make a Docker file now. Just run touch space Docker file. And the convention is always to just name the Docker file with a capital D, and you put it in different directories. And let's open it up in VS Code. And let's go ahead and build a Docker file to do what we just did manually. And sorry for the confusion there. So a Docker file needs to start with an existing image, the base image. Ours is going to be Ubuntu and the latest version. So go ahead and add that on line 1. I'm going to paste in a command into the Zoom chat. And I just go ahead and paste this one in, or if you want to type it out, you can. I'm going to do it now. We need to avoid those interactive command line prompts. Like, yes, do you want to do this? No, because this is all going to happen automatically. And I don't know exactly what this environment variable does, to be honest. Though the setting we're giving it is pretty telling. We're telling the shell and these programs not to prompt for user input for stuff. Now we use the run command to do exactly what we did on the command line. And we need to do apt-get update. And what we can do is just put multiple stuff with one run command. So I don't have to do run, apt-get, install, run this, and run that. I can do the 2 ampersands to add multiple commands. But what's even nicer is I'm going to put this on multiple lines, and I'm going to use a slash to do it. I'm going to tab this in, but that's just for readability. I'm going to be totally honest. I'm not exactly sure what this -y flag does. I've got a little script here that I'm following. This would probably work okay without it.
I
And
think
then,
that should be for when it asks you yes or no if you want to continue with the install.
James, thank you so much, man. That makes so much sense. Then I was totally wrong, and this -y is super important. Do you know what this Debian front end environment variable does?
I do not.
Me neither. I'm gonna Google it once this is done. So I'm curious. But yeah, thank you so much for saying that. So this -y is actually super important. I don't think we can add a comment there. And we're going to install Git. And this is also me sort of following from a script here of, I think there's some like temporary files that get created that we are just going to delete. I don't think we need to set a working directory. So I think this will do it for our Docker file. And now let's try the build command again. And the important thing here is we're going to run this build command in the same directory as our Docker file. And fingers crossed this will now work. Docker build, let's just do ub-1:v1 Docker build -t. Been looking at the screen a little too long. And now this dot tells Docker, look in the current directory for the Docker file. If we wanted to, we could do like backend. But we're going to use this Docker file that we just created. And now I think this is working. And is this working for folks? Were people able to get to this point? I see some thumbs up. James Cromer, I saw you shaking your head.
Yeah, I got a error about not being able to run, and it was because of a typo, and I'm fixing it now.
No problem. I know too, like typing along with this is not ideal. So, and I'll of course push all this code up later. And there's a number of examples of this too. This is sort of a hello world. And I just put the code in the Zoom chat as well. So now what we've done is if you type Docker space images to list all your Docker images, we just created a Docker image. UB1 version 1. And if I go to Docker desktop, I see it in here as well. And now what we can do, which is pretty cool, is push this image to Docker Hub. And the way you do this is Docker push, and then you need to have it be your Docker Hub username. So you might have to check that, and /, and then it should just be the image name and the version name. So let me just kind of repeat that and highlight it. We're going to do Docker push, and this needs to be your Docker Hub username. So I always forget my usernames for stuff. So I just go to Docker Hub. And if you go all the way up to the right and right click where you're logged in, you'll see your username. And username /, and then the convention is you should name this the same as the image and the tag for simplicity. And I'm going to go ahead and let's see, what did I do wrong here? Invalid reference format.
UB1 tag, it's tag 1.
Yeah, thank you. An image does not, let's see. I think I got my tag. I think I got something wrong with my push syntax. Let's make sure I have this right. Username repository tag. An image does not exist locally with the tag. Yeah, I just did do this earlier.
Should your tag just be V1?
I think it might be the dash. Let's see if yeah, let me, an image does not exist locally with the tag image ID. So here's repository. Do I have to? My apologies, folks. I did this earlier, but it already. I think the repository already existed. Let me do a quick Google search here just to see which step I missed here. I thought the image was already tagged, but maybe I'm wrong here. It looks like we need to do an explicit Docker tag command. Let's see. Docker push host name. I forgot to tag my image with the username. Let's see which step I missed here.
Maybe able to just use push by itself.
Okay. Maybe. I'm totally using ChatGPT here for some help. And I think I just missed the step. So let's try this. Let's try this again. I think let's try using the image ID. Docker space tag image ID, my local image. Let's try ub-1:v1. And I think you're right. I do need the username. Let's see if that does it. And now let's see if the Docker push command works. Tag does not exist. Oh, ub1. There we go. Okay. I'm so sorry about that, folks. Just to reiterate, there's two steps that need to happen here. We do need to tag the image. I totally jumped the gun and I thought that happened automatically. So we're going to do Docker tag. And let me go ahead and clear and I'll just show both these commands again. So Docker tag. And then we can use our image name and image tag. So ub1:v1 space, and then we need our Docker Hub username / and then the name we want to give it on Docker Hub, which should be exactly the same. ub1:v1. And was everyone able to run that tag command successfully? Awesome. And so once you run the tag command, the push command,
I got an error.
I'm sorry.
Sorry, I got an error.
Oh, what error did you get?
It said failed to do request head, and then it gave me a very long URL. Dialing my username and then 443 container, etc.
Okay, let me circle back to that one at the end.
Sure.
And once we have the tag, we then push with Docker push username and image name and tag name. And Juan, I know this won't have worked for you. Were other folks able to run this step successfully?
No, it's saying I need to. The push access was denied.
You might need to run Docker space login.
Okay.
So I don't think so. I saw a couple nods. I saw it worked for some folks. Is this not working for other people as well?
Can you go back to that tag command real quick?
Yeah, totally.
I still get the same error after logging in again.
Let me see if I can figure out what's going on there. Oh, and we might have to tackle that one separately. I would just double check that the username you used in the tag and push commands is the same as your username on Docker Hub.
Gotcha.
And just to confirm, did this work for anyone? Okay, I see a couple thumbs up. And I realize we've ran long as well, so we should be wrapping. I'm more than happy to stick around to help to debug the issues, but the end state of our journey here is if I go to my Docker Hub now and I go to my list of images, up there is Atom C UB1. And if anyone wants to, you all should be able to pull this down with Docker pull. And if someone wants to paste their, I'm just gonna grab the name from there. If someone, let me paste that in the Zoom chat. It would be Docker pull Atom C / UB1 V1. Oh, and nice. And if someone else wants to paste in their username and stuff, then I can pull down one of your images. Okay. Oh, and awesome. Let me go ahead and use yours.
Yeah,
So-
I don't know how I pulled my username, but it just
Yeah, there's always stuff with this. Pull access denied for user 26. Did I get this?
put a dash in between the UB dash UB1.
Oh, I totally forgot the UB1. Oh, and Juan, thank you as well. No matching manifest. Juan, let me try yours. I wonder if this is a Linux thing. Yeah. Oh, and if I had to get one, are you on a Mac?
Yeah, I am.
Yeah, so I don't know what it is, Owen, but there must be maybe it's some subtle thing with being on Linux or a default setting or something. Which just goes to show how hard this cross-platform stuff is, because if you think about everything Docker is doing and we still run into these issues. So, and where I wanted to go with this, and let me make a little directory here, is I can go ahead now and I can Docker run it -- name, and we'll just do I'm gonna go really simple with the naming convention. One official UB1. Let me make sure I
It was
have
V1.
there we go. And so now I'm running Juan's Docker image. Right? Which we've done so little, but it's really cool because this is not just about installing Git. This is about you can have a whole web app in here. And what I want to close with, and it took us a while to get here, but this is the coolest part about Docker. I'm going to go into this directory I made. I'm going to make another Docker file. And we're going to use as the base image Juan's image, the one that was built off of our other Docker file. I'm going to copy this stuff. I'm going to put it in here. Because what I want to install now And let me go ahead and go in there so I can show you. Oh yeah, I can just do Docker start. The syntax is just always tricky with Docker. So what I really want to do in here is I can make a file. It'd be really great to edit it. Vim is not installed by default on this version of Ubuntu, which is a command line text editor. Neither is Nano, another command line text editor. So I want to install the Nano text editor so I can do, I can mess with files on here. So I'm going to have to update apt-get again. And it's doing its thing. And now I want to install Nano. And now I can use Nano to edit a file. I can say, hello world. I'll hit Control X to exit and Y to save the file using this ancient, command line text editor, which apparently I still got wrong. So we'll just write out, there we go. And now we exit. And if I print it out, I've got my text there. So this is great. But I run into the same issue where I want to share this with the whole world. And so we're going to now have a different file where we install Nano off of the old image, right? So we had one Docker file to build off of a base image of Ubuntu where we installed Git. And now we're using that image and we're adding Nano. And it's kind of inception-y or like Git commits where you build things one on top of another. And Git and Nano are really simple examples, but think about Python, Nginx, Postgres, Django, right? This is how, if you start poking around on like different Docker files for official packages and stuff, they're all built on top of other ones. So I don't know if this is like exciting to you guys, but I remember when I kind of learned about this, I kind of felt like my mind was blown a little bit because it's like instead of Git commits with lines of code, we're doing it with like whole operating systems where we get to put one on top of another on top of another. Because now I can, now that we have the syntax down, run the same command if I eventually find where I did it with my tagging. I'm going to call this UB1 V2. So Juan, I apologize. I'm stealing your thing and I'm using it for my version 2, but I'm going to go ahead and build it. And it's taking a minute, but it should be done. And now I'm going to tag it now that I've properly learned how to do that. And we're just going to change this to V2. And I'm going to push it up to Docker Hub. And this line layer already exists because I have V1 image already. Docker doesn't have to do that work again. And it's exactly like Git commits. It's like James was saying, we have both like requirements txt, and this is sort of like Git commits for like an operating system. And now if I go here and I click on UB1 and we look at tags, we've got V1, V2, and if I took the time to add good descriptions, we could add those. And on the GitHub, I could have the Docker files. And all of a sudden, like we can like exactly reproduce the system and document really nicely how to do it. So this was a bit of a journey, but this is like a key Docker concept. And if you like look around, um, like Docker, like here's someone who has set up a sort of production ready Docker Django thing, and they're building off of Node for something. Um, they're using, again, another Docker image for Python. So you can just, depending on what you want to do, just stack images on top of each other and in your Docker files, which is super cool. So this was a bit of a deep dive, but hopefully it kind of like illustrates more of what Docker is and some of the power of it. As long as we're doing this, I think we might as well close out by using Nginx. And I'm going to borrow from the DevOps curriculum. We have a web app made by one of our instructors, Chandra, who's awesome. And he basically made a really simple game. And it's just, there's no React.js, it's just HTML and JavaScript. And I'm going to go ahead and paste the link in here. And what we're going to do is we're going to use the Docker Hub official Nginx image to host and run this website. And then we'll wrap up because I know it's been a long morning. So thank you for bearing with me. So I've put the GitHub repo in the Zoom chat. And what I'm going to do is first close out all of these files because we're not going to need them. And I'm going to make a directory and let's just call it website, or if you want, Chandra website, just something. And we're going to clone into there. I guess I didn't need to make a separate directory, but that's okay. And so what I've got is a website that lives in this 2048 directory with an index.html. And then we've got the Nginx Docker container. And they tell us here how to use it. And I'll put this in there. And I'll just copy and paste the command as well, because we're going to put it in and we're going to modify it a bit and we're going to talk about it and we're going to run it. So the command is the command is Docker run, and this will pull down the image automatically. Whatever name we want to give it, some Nginx is fine. -v, this is what you were asking about earlier. I think it was Juan, about volume mapping. Like, we're going to tell this Nginx web server, look on the host file system for stuff. And then map this directory to this directory inside the image. And this is where our web server is going to look for HTML files and web content. I'm not sure what this RO at the end does here. -D means run in detached mode, so that this will run in the background. So we're going to do Docker space run -- name. And I'm just going to do my web server -v, and I need to give it the path to where this HTML file and its assets are. If we had a built React.js app, we would do this. and then colon. And I need to use exactly what the Nginx Docker image says in the docs, because this is Nginx already set up inside the Docker image. So look in this specific directory inside the image. And I don't know what the RO is, but they say they need it, so I'm doing it. And then I give it the name of the image to use, and Docker will pull it down for me because it can't find it locally on my computer. And I'll go ahead and I'll paste this in for folks. And I'm curious, was anyone able to get this to run? Haley, awesome. And if I type Docker PS, Docker space PS, I should see this container running now. And it's running on port 80. So now if I go here, and let me make this big. Let's see. I think I forgot a key step. I may have missed it in the copy paste. Oh, I forgot the port mapping. So I do apologize. So what I'm going to do is, and the problem here is this port is inside the Docker image, right? If we were to do TL draw real quick, if we've got my laptop, and let's make this bigger. And my laptop has a lot of space. Over here, we've got my browser running on my laptop. And over here, we've got the Nginx Docker container. That's running that image. And inside there, Nginx is listening on port 80, but we have not exposed or mapped that port inside the running image or container to an external one. So I do have to do a Docker stop my web server. And I'm not sure if I can add the port mapping. We might have to delete the image, the container, and rebuild it. And let me make sure I get the mapping right, because this is what I did wrong last time. We do host on the left to Docker container port on the right. Yeah. So what we're gonna do is I'm just going to do Docker rm my web server and delete it. And we're going to do the run command again, and I'll paste it in. And I'm just going to put the port mapping here for simplicity. So 8080 on the left on the host to port 80, because inside the container, Nginx is listening on port 80, so it has to be there. And let me paste this in the Zoom chat again. And now if I type Docker space PS, we see in ports here, there's this mapping that wasn't there before. And now if I go to localhost 8080, fingers crossed, there we go. We have this web app game. And so if we wanted to, we could bundle this into the image. But what this does this way with the volume mapping that the other setup doesn't do was, if I modify this, and I go here and I refresh the page, we have our change, right? Because the Docker container is sharing part of the file system. And somewhere around here, I have a diagram to that effect. This one is actually for Postgres because we have to do the same thing. But this is what the Nginx container is doing, where we have our file system, we have Docker desktop, we have the Docker container, and then when we do the volume mapping, we tell Docker, hey, when you run this image with this container, share a part of the file system with the host so that both can interact with it. And was anyone able to get this running and have that website run successfully?
I fell behind.
When I see you shaking your head.
I fell behind, so don't worry.
Okay, I know I rushed a bit at the end. This definitely went longer than planned, but I hope it was useful. Hopefully, when we got to the end of the journey, did we feel some excitement? Okay, awesome. Yeah, Docker is super cool. It really is this inception-y kind of thing. Like, just to recap what we built with the images, we had the Ubuntu base image. And then on top of that, we added, let's call it UB1 V1, which was Git. And then on top of that, we added UB1 V1, which was Nano. And to be honest, I wanted to do this with Python and Node.js, but there were so many steps involved with installing Python and Ubuntu and different ways to do it that I just gave up. But in theory, it would be exactly the same way that we would construct a Docker image for Ubuntu that has Python on it. And in fact, if we search for Docker Hub Ubuntu Python, we find an official Canonical is the company that sort of runs Ubuntu, a chiseled Ubuntu rock with the Python runtime from Canonical. And while there's more steps, they built this Docker image the exact same way we just did ours. So thank you, folks. I know this was a long one. I'm glad it was useful and I hope it was interesting as well. Now that we kind of like have a sense of Docker, we've gotten our hands dirty with it. What we're gonna do, and these will be shorter. I will do my best to keep them not running like the full length like this one did. Is we'll actually take a full stack app. It's going to be that wine app, and I'll share the GitHub repo link, and we are going to Dockerize it over the next couple days. And in fact, let me just show you all, and then this can be our kind of closing point here. If I can find this is what I want. So I think this is what we'll use to Dockerize. I might make some changes. And if you look, what you'll see is there's a branch here that shows the web app just with Django and Postgres Dockerized. We didn't talk about Docker Compose a ton, but this is complicated because it's a full production setup with shell scripts and stuff. And then there's one that adds the front end stuff with the web server, and then the main branch. And the README has how to use and install instructions on each branch that are up to date and correct. And then the main branch itself has everything sort of in its final form. So I'll share this link, but I just wanted to point out the different branches because I think that could be useful to look at like the two different steps of this. There's some extra stuff here with Redis and things that we don't have to worry about at the moment. Thank you all very much. I appreciate the time. And again, I'm glad it was useful. let's definitely break. I'll open up the breakout rooms, and I'm happy to stick around a bit to help debug or ask questions. I just want to give people back time since we had such a long lesson. So, and I'll get this video posted in a bit. All of the images will go in our demo and notes repo along with the sample code. So thank you very much, everyone, and have a great lunch.